다음은 프랑스 몽펠리에대학의 장 부스케 명예교수의 발표가 있겠는데요. 장 부스케 교수님은 전 WHO 산하의 만성호흡기지로한 퇴치 국제연맹 의장을 역임하셨고, 천식 분야 내 가장 영향력 있는 저자로서 전 세계적으로 가장 많이 인용된 생물의학 저자 탑 400으로 선정된 이력이 있으신 분입니다. 최근 논문에 발효배추가 코로나19 사망률을 낮출 수 있다라는 연구 결과를 발표하면서 김치를 언급해 큰 화제가 된 분이시기도 합니다. 교수님께서는 코로나로 인해 한국 입국이 어려워서 교수님의 발표 영상을 저희가 따로 준비를 하였습니다. 주제는 김치의 항코로나바이러스 효과입니다. 영상 시청하시겠습니다.
Hello everybody. I would like to discuss with you kimchi. Well, in Korea and in Eastern Asia, we are very lucky because you didn't have many deaths, and now you don't have an increase in cases of COVID-19. Is it possible that kimchi is a possible food prototype for the control of COVID-19 by nutrients? I would like to give you 4 points. First of all, death rates in countries and regions. Secondly, ecologic data on food consumption in the EU. Thirdly, possible mechanisms. And finally, is kimchi a possibility? Well, the death rates in countries and regions have been well studied. It is clear that there are many different possible risk factors. The contact with the person who is infected, the intensity of social contacts, the intensity of occupational contacts, masks, confinement early measures and level, climatic conditions, age of the population, and the GDP of a country or region. And we know that we have plenty of examples in Europe, in the US, in Asia, that can assess all these problems at the individual level, but also at the country level. However, one factor which has not been well identified is diet. We started a long time ago, in April 17, 2020, discussing why in Europe you have a gradient from the west to the east. In the west you have a high rate of death rates. In Central Europe you have less. And then when you go to the former Eastern European countries and the Mediterranean area, you have much less death rates. And discussing with a friend, we found that in Poland, cabbage and fermented vegetables are common in the diet. So is this a possible explanation among all the others? Well, we now need to go into the different countries, and I would like to discuss Italy, this state which is on the right part of the slide. In the northern part of Italy, death rates were over 1,000 per million. In the southern part of Italy, death rates were under 50. And same genetic background, and this suggests, again, that food are involved. But one of our friends said, well, the map of coronavirus deaths is similar to metabolic syndrome and the differences in food chain supply. So we had a second thing to do it. Now we go to the world, and it is clear that in dark green, very low death rates. You have Asia, Australia, Africa. Well, in Korea, you eat a lot of kimchi and fermented foods. But also in Asia, people eat large numbers of fermented vegetables and spices. So is this possibly involved? When you go to Africa, of course, the population is young, but almost 1 billion people rely on fermented food, cassava. And in some countries, it accounts for over 50% of the diet. They eat many other fermented foods and large numbers of spices. If you go to the slum paradox, in India, in the slums in Mumbai, over 50% of people have some COVID infection. But very few are hospitalized and even fewer died. this may be related to the age of the population, but also because they eat many fermented foods, many spices, including obesity, including curcumin, and low obesity. Finally, it is clear that there is a relationship between obesity and low COVID death rates. If you look to the upper part of the slide, in green, you can see low death rates, and except for Australia and New Zealand, it is clear that there is something very interesting. If you go now to men obesity, the same ratio is found. And this is highly surprising. And this is not the case for diabetes. And you know that obesity is more involved in risk factors for COVID than diabetes. So, taking all this into account, and taking also into account that diabetes is associated with diet, we thought that diet may be one of the risk factors of COVID or a preventable factor. There are ecologic data on food consumption in the EU. And what we did two studies. The first one, we assessed fermented foods, and the second one, the consumption of vegetables. In Europe, we have a database, which is the European Food Safety Authority Comprehensive European Food Consumption Database, where you have plenty of country consumption of foods, and that you can relate this with eventually death rates. So we did it, and we found, number one, that when you eat more fermented vegetables in Hungary, Poland, Czech Republic, Slovenia, Latvia, Estonia, you have lower death rates than in places like Belgium, UK, Sweden, France and Netherlands, where we eat far less fermented vegetables. Now if you go to the vegetables, we found two, head cabbage and cucumber, with about the same countries. So this study, although it is not the best scientific study, but it's impossible to do it now because time is running fast. So this is suggesting that foods may be involved in COVID-19. Well, now we need to go to the possible mechanisms. Which are they? First of all, when SARS-CoV-2 arrives in the nasal mucosa, it binds to receptor ACE2, angiotensin converting enzyme 2. And this enzyme, when it exists, is acting on angiotensin 1 in order to go to the blue mass pathway, which is preventing the oxidative stress. However, when the virus arrives, then this enzyme is downregulated, and you go to the green pathway, which is angiotensin 2 with AT1R receptor. And this is associated to oxidative stress. And we know that COVID is associated, most of the COVID symptoms are associated with oxidative stress. Insulin resistance, lung injury, endothelial damage, and the cytokine storm. So this may explain, at least partly, why there is some oxidative stress in COVID and why it is important. And very interestingly, the most important factor in the human body to counteract oxidative stress is the transcription factor Nrf2. Now, when the virus enters the cell, it induces a reticulum endoplasmic stress response, which again induces oxidative stress. So there are two pathways which may be explained, or which may explain why people with COVID have an oxidative stress, insulin resistance, obesity, diabetes, hypertension and aging, lung injury, endothelial damage, and cytokine storm. The next point is, are they activators of Nrf2? And interestingly enough, cabbage and fermented vegetables, which are found in kimchi, are highly activators of Nrf2. Cabbage, because it releases glucoraphanin, which is a product, and myrosinase is also in the cabbage, but also in the gut. inducing the synthesis of sulforaphane. Sulforaphane is the most potent activator of Nrf2. But you have also lactobacillus, which is another activator of Nrf2. So, it is possible that cabbage and fermented cabbage, like you have in kimchi, are extremely important in reducing oxidative stress in patients. Well, we have studied many Nrf2 interacting nutrients like berberine, curcumin, epigallocatechin gallate, genistein, lactobacillus, quercetin, resveratrol, sulforaphane. They are found in many places, in many foods, and particularly vegetables. And they are acting on the pathway AT1R, on obesity, on hypertension, on diabetes, on the endothelial damage, on aging, but also on lung injury and IL-6. So it's very interesting to see that Nrf2 interacting nutrients, which are found in many vegetables, are also acting on all the pathways of COVID. The next point is, what are the mechanisms? Increased Nrf2, reduction in mTOR, increase in PPR gamma, reduction in F-kappa B, increase in ERK, and reduction in ELF2A. And this is for all the different compounds we have selected. So there is something which is striking for me. It is that all Nrf2 interacting nutrients act the same way and act on all the COVID different pathways and symptoms. So this is something interesting to me. Then there is another one, is TPRA1, transient receptor potential A1. Well, this potential is inducing cough and lung injury, nasal congestion and smell dysfunction, digestive symptoms and taste dysfunction. It is activated by reactive oxygen species, that is to say, it's active by oxidative stress, which may make a link between COVID and the activation of this receptor. This receptor can be induced by cigarette smoke, pungent foods, and air pollutants. And in fact, it is possible that acting through Nrf2, you are acting on the metabolic syndrome, on lung injury, on endothelial damage, on cytokine storm, but also on virus replication. Acting through the transient receptor potential channels, you're acting on cough and lung injury, on nasal congestion and smell, on digestive symptoms and taste. And these are the symptoms of COVID. So, since the Nrf2 nutrients are also acting on TRPA1, it is extremely interesting to think that the same nutrients are acting on Nrf2 and TRPA1. Well, not all, because allicin for garlic is only a TRPA1, and mustard oil is also an TRPA1. But ginger oil, lactobacillus, quercetin, red pepper are both Nrf2 and TRPA1. So it seems that these Nrf2 TRPA1 agonists may be involved. Let's see now in the clinic. Well, this is me. By the way, I got COVID and I did bronchial challenges with broccoli capsules. What is striking, it is that you see the induced cough challenge. What is striking is that after 5 to 7 minutes, the broccoli is effective. Extremely effective and extremely rapid. This is not something on the oxidative stress. This can only be a receptor mechanism. And the placebo didn't induce any effect. Now, I studied many different nutrients, broccoli, green tea, curcumin, resveratrol, which are TRPA1 and Nrf2. Berberine only, it's only a product of Nrf2, and zinc is both, but it didn't work. What you can see on the left-hand part of the slide is that curcumin is effective in 1 minute. 1 minute! Can you believe it? And I did possibly 15 different challenges to show that. And then I use also this product because I still have some cough. And you see I didn't cough today yet. Some cough and some nasal obstruction. So, we think that the TRPA1 mechanisms are acting very fast. And then, if you combine not only broccoli, but also broccoli and green tea, broccoli and resveratrol, broccoli and curcumin, in this case, you have a very fast reduction which is sustained. Next, the duration of action. Unfortunately, curcumin is acting only 2 or 3 hours. Resveratrol is acting 4 hours. But if you combine broccoli Nrf2 plus curcumin or TRAP1 or broccoli plus resveratrol, you go from 6 hours in broccoli and 2 hours in curcumin to 8 and 9 hours. Now, if you go to something else, if you add paracetamol, paracetamol increases the duration of action to 13 to 16 hours. And I did at least 6 challenges and many different, I'm taking this regularly now. Why? Because paracetamol metabolites are also activating TRPA1. So I think that we have now some idea of the foods, the mechanisms, the studies. Well, in myself, I have also 7 clinical cases now showing that in fact these nutrients may be extremely interesting in protecting patients. Well, kimchi. Well, kimchi, you have plenty of kimchi, and it's not only kimchi, but I'm not going to tell you the names because my Korean is not good enough. But kimchi is widely consumed in Northern Eastern Asia countries, including Korea. And among them, kimchi is the most popular Korean traditional food. It is prepared from cabbage, and the main ingredients are cruciferous vegetables, so a lot of sulforaphane, and other healthy foods such as garlic, ginger, red pepper powder. Garlic is TRPA1, ginger is TRPA1, and red pepper powder is TRPV1. And these are acting. So, in fact, at the beginning, you have a lot of sulforaphane and a lot of agonists of TRPs. But on top of that, you have fermentation. And it is very interesting because there was one paper by Gao published in 2012 showing that if you take fresh kimchi or fermented kimchi for a few days, you are acting more on pre-diabetes with fermented kimchi than with fresh kimchi. So there is something else in the fermentation. And the lactic acid bacteria possess antioxidant activities and are potent activators of Nrf2. So, to conclude, we have in kimchi garlic, ginger, lactobacillus, mustard oil, quercetin, red pepper, sulforaphane, and vitamin D. And all of this are acting either on Nrf2 and TRAP1. Well, ladies and gentlemen, for me it's simple. Kimchi may be one of the major reasons for low COVID death rates and severity in Korea, and possibly for the low level of infections you see now, in contradistinction to Europe and the US. It may also prevent infection by SARS-CoV-2. These benefits may be related to Nrf2 and TRAP agonists. Kimchi may therefore represent a possible food prototype for the control of COVID-19 by nutrients. And I would like to finish by this slide. Well, you go from the left, very bad, to the right, very good. In the left, you have large western megalopolis, London, Madrid, Milan, New York, Paris. You have long chain food supply. People eat very few vegetables, very few fermented vegetables. Then you go to smaller cities, the countryside of western cities. You have short chain supply and it's better. You go to the Mediterranean countries, like southern Italy. I showed you that in southern Italy people have less deaths. Mediterranean food and other foods are quite interesting. Finally, in Eastern Asia, in Central Europe, in the Middle East and others, you eat cabbage, fermented vegetable and spices, and you are prevented from severe COVID-19. So, what should we do? Possibly to supplement patients with sulforaphane spices and also lactobacillus, not only for dietary mitigation, but also for food supplementation. And this may be a possible treatment of severe COVID-19. So, ladies and gentlemen, kimchi is an excellent food, very tasty, and luckily it's also a very good food for you. Thank you.
네, 발표 영상 잘 봤습니다. 해외 석학 연구자의 관점에서 바라본 채소, 발효채소 또는 김치의 효능이라는 점에서 김치의 가치가 더 의미 있게 느껴지는 시간이었습니다.